So if you've listened to any of my other videos, I'm sure you've heard me talking about the fact that when it comes to nutrition, I believe for a lean physique, you need to be on either end of the scale of either being on a very low carb diet with high fat, or way on the other end of the scale where you're having low fat, but you're also having high carbohydrate. It's on either end of the scale that it tends to work for keeping a lean physique, but it's in the middle, in the gray area, that tends to not work so well for people. But what I wanted to talk about in this video is why being in ketosis can be quite magical for having a lean physique, how the biochemistry works, and in another video, if you're interested, I'll talk more about the other side of the scale and why that can also work. But when we think about being in ketosis, what's really interesting is that we end up depleting something called oxaloacetate. You don't really need to know too much about it. All you really need to know is that when we go through metabolism, we have something called the Krebs cycle. And one of the intermediates of the Krebs cycle is oxaloacetate. And hopefully I'll show a picture here. What's interesting is there's two things that are depleting our oxaloacetate when we're in ketosis. One is when we go through beta oxidation, which is the breakdown of our fats, whether it's body fat or the fat we've ingested. We end up basically producing a lot of NADH, and we end up depleting our NAD plus levels. This prevents us from being able to convert malate to oxaloacetate, which then in turn ends up depleting our oxaloacetate levels. Another thing that happens when we're in ketosis is we want to go through something called gluconeogenesis, and we inevitably are going to do this when we're in ketosis because we're not ingesting carbohydrates. So our body needs to produce a little bit of our own carbohydrates endogenously, which is going to happen in everybody, and that is called gluconeogenesis. And this process in itself is going to deplete our oxaloacetate levels as well. So what's really interesting though is that we need oxaloacetate to combine with something called pyruvate in the Krebs cycle to produce something called citrate. And it's that citrate that we actually need to be able to produce new fat. So what's really interesting about it being in ketosis as opposed to not is that we don't have oxaloacetate to combine with pyruvate and convert to citrate. Now, in other videos as well, I've explained this mechanism, but essentially when we are going through the Krebs cycle and our body is deciding, okay, we need to start building new fat, we have too much energy coming into the cell, and we're going to switch over from burning energy to building new tissue like fat, we require an excess of citrate. But remember how I just said, when we're in ketosis, we are depleted in oxaloacetate, so there's nothing to combine with that pyruvate to be converted to citrate, and therefore we never end up having high levels of citrate, which signal parts of the cell to say we need to start building new fat. Because it's actually that citrate that is part of the first steps of the process of making new fat. So I think that's really fascinating here. And so what ends up essentially happening is because we don't have that oxaloacetate to combine to pyruvate and form citrate, we just end up getting this buildup of acetyl groups basically. And they go through another pathway to make ketones. And ketones, as you probably already know, are basically just two carbon molecules of acetyl groups that are stuck together and they form ketones. And what's interesting is we end up making, two types of ketones, acetate and beta hydroxybutyrate. And so the only difference between these ketones is that the beta hydroxybutyrate has taken on some of those extra electrons from the NADH, and that has basically converted it to beta hydroxybutyrate. So what's also interesting about this is if you know anything about NAD plus from my other videos, you'll know that having too much NADH is what also slows our metabolism. But in fact, it looks like beta hydroxybutyrate is our way of taking on those extra electrons so that they don't build up, and potentially this is what keeps our metabolism going. So in summary of this video, what I'm talking about here is there is a magic in being in ketosis and being on this end of the scale where you're eating very low carbohydrate, very high fat, and the fact that it depletes our oxaloacetate levels in two mechanisms. And this means that we can't combine our oxaloacetate with pyruvate to produce citrate in the Krebs cycle. And it's the molecules of citrate that start building up that actually are a signal to the cell to say we need to start building up new tissue and new fat. And so if we don't have any citrate being produced, then we can't really build more fat. And so once the fat is liberated from our fat cells or available in our bloodstream to go into the cells to make energy, we can't really then go and convert that to new fat like we would in other situations when we've liberated that fat and we want to start using it to build up new tissue, essentially. So I hope this makes sense. I hope you're still with me, and I hope you found that interesting. Until next time.